thing as well. Does this work? No, this doesn't work. That does work. Okay, all good. Kind of works. That'll do. What does that one do, guys? Anything? Okay, I'll not touch that one. Right, cool. Where am I going to stand? Stand here. No, I'll stand here. So, yeah, last talk of the event. So, hopefully you guys are still awake. Basically, I am Andy. I am the engineering manager at Alba. So, I'm going to talk to you about. Well, okay, so I'm the engineering manager now. I was the manufacturing manager, so that's why I'm going to talk to you about manufacturing. Talk to you about ramping unicorn production, the Alba adventure, because that's very much what it is. So, everyone, this definitely doesn't properly work. There we go. Okay. So yeah, I mean, Alba has been an epic adventure for me, I have to say. I've been about 7 years with Alba, and I started off. I responded to an advert because Tom was talking about sending things up to space, and it sounded just pretty cool, and it sounded like he was game for a laugh. So I thought, right, I'll give it a wee shot, you know. So I got in touch with Alba, and then I started off as a software engineer. So I used to write engine management software, amongst other things. So I was like, right, you can help out Tom there. So came on doing software, but I was probably spent about 10% or less of my time writing software. I ended up bug fixing hardware because, I mean, basically the hardware wasn't working right. So I had to fix that first. Kind of eventually, I suppose, we got the hardware working on Unicorn 1. Things moved on. We moved to Unicorn 2. We got funding from 𝗖ście and stuff for Unicorn 2. So yeah, just kept on writing software. We got another software guy on, moved to, you know, kind of just making stuff happen, I suppose. That's kind of, I would say, if it was my strong point, I would say making stuff happen was my strong point, really. So that's what I spend my time in Alba doing. So ended up doing ground station stuff. We needed a ground station building. Obviously, we get satellite. You need a ground station as well. So I was doing RF stuff on there, ground station radio building. Then I started moving into the manufacturing stuff. I was doing manufacturing for about 4 years or something, like ramping things up from basically nothing really. Like before we had a lab, then we got the lab on the go, and you just got a wee team on the go. We've had a manufacturing team of about like four guys. Me myself, a procurement guy, a couple of techs. We had administration guy as well. So yeah, a few people involved there. Now I'm doing manufacturing. We sadly missed Constantine, who went back to Greece last year, so I'm trying to fill his shoes. So the engineering is great fun as well. But that's probably where my passion is anyway. So I'm very happy to be in that role. And yeah, basically it's just been an epic adventure. Tom keeps throwing intractable problems my way, and I do like an intractable problem. Basically, yeah, he keeps throwing me interesting work. So I'm still here 7 years later. Still can't work one of these though. So timelines. Basically, I'll just go over this briefly. I'm going to talk about this in more detail. So back in, you can just about see that. December 2019 is over on that side of the projector. So we've got Unicorn 2 B and C. They were initial star project. They started about 3 years before 2019 with some 𝗖ście funding. We flew them in 2019. We received a transmission from U2C before it deorbited in sort of mid 2020. We flew Unicorn 2A, D, and E December 21. We established contact with U2D. It was just alive, but it was a wonderful, wonderful miracle that it was alive, because like the difference between having a satellite to talk to and just sending something up when it's just dead as a dodo, you know, it's just like night and day, you know, it's incredible. So yeah, that was okay, so that was the first time we decoded any data. So we'd established contact with U2C before then, but we actually managed to decode the data and speak reliably for a good few months with U2D, which was fantastic. U2F spoke to us once, sadly. Well, it was better once than none at all. U2G and H were entombed in a launcher deployment failure, so that wasn't our fault. There was a failure a couple of years ago with a launcher deployer. U2I was sadly dead on arrival, but U2J and K are talking to us very nicely at the moment. So we're expecting to get some images off those. Hopefully by the end of the year, we'll see what happens. But certainly they're looking very healthy just now. So we've done a load of work on the power budget. The power budget was really what let us down on U2D. And then so there's a few sort of key dates in there as well: launcher deployment failure, ground station upgrades and stuff, launch cancellation. But I'll go into those in a bit more detail in here if I can work this. No, I can't work it. Unicorn 2B. So this was our first deployment, as I say. So it took about 3 years from start to actually hearing our beeps from space. So that was the team then. There is where's the little star? There it is. So there, does anyone recognize that? That is 𝗖cie. There's Mr. Tom Walkinshaw. That's Constantine. Martin Dunn. Greg. Rest in peace, Greg. Chris. Bence. And I'm hiding in there behind the window. And there's Alan as well. So there's a few of those guys still with us. So obviously we're going to talk to you about the manufacturing. You guys are probably, I imagine, most interested in the manufacturing. So the early issues. So I mean, we were just kind of like, in the early days, we were just building. We're just like, okay, so we've never built these things before, and so we're going to do our best, and we, build these things and get them out and try and get them working, right? So there was a lot of concentration on separate subsystems. Each designer would take, take their separate subsystem and think about that and get it working. And then when we came to putting it all together to actually build it, it was like, holy moly, this thing is unbuildable. It's like a total nightmare. We were trying to solder, 8-core cables into 1 millimeter, PCB through holes, and we were just like, we're having to chop little strands of wire off to get them in. It's just like, this was like a few days before the flight. It's just like, it was total madness. So there was a lot of concentration on separate subsystems. So the integration was really bad. But you learn by your mistakes. The total essentials were fixed to make it so we could just build it. The connectors in particular were reworked, just so we weren't having to solder wires into through holes. It was still difficult to build and get it repeatable, but it was a whole load better. And that took us on to A, D, and E. So D, we got a whole load of telemetry from U2D. So as I say, that was a wonderful miracle that it worked, really. It was barely alive, but it was alive, and it taught us a whole load. So we had power issues there. This guy is just some random guy. I think his name's Tom or something like that. So he was just happened to be in the clean room at 2 o'clock in the morning when we were shipping these things. So process. So the process for A, E, and D was really right. We build it. We build the whole satellite. We test the whole satellite. We discover the whole satellite doesn't work. We unbuild it. We break something else. We rebuild it, and we break something else, and we test it, and then we repeat that process almost infinitely, So we're like, we set ourselves a target of building 9. Once we got our investor money, we set ourselves a target of building 9 in one go in a very short space of time. And we're like, we don't have time to get this wrong and then unbuild it and then rebuild it and unbuild it. So we had to get it right first time. So we thought, right, we've got to toughen up our process. We've got to improve our process. So we needed to improve it so we wouldn't have to rebuild it. So we defined the process and added some quality control gates. We would test the subsystems, before actually integrating them onto the satellite. So, which sounds a bit like obvious and common sense, but some of the techs that we got in were like, well, that's really good that you do that, because we didn't do that at our old place. We just built a whole system and then we would just like rip it apart and try and build it again, So it sounds a bit crazy with the hindsight, but it maybe wasn't so crazy that what we're trying to do. We were breaking ground. Nobody's really done this much before, so I don't think we should be too hard on ourselves. But as long as we're getting better. So yeah, we were always building on top of successfully tested hardware. We saw much better results, less rebuilding, which took us on to these. So F to N. So these were a batch of 9 satellites that we pushed really, really hard to build. So we ended up not being able to launch those satellites because we had an issue with our launch provider. The batch that was booked onto the flight fell through at the last minute. So we got left with a whole bunch of satellites sitting there on the shelves, which were sort of like very nearly finished. But they'd been done in a hurry, so there was a few quality issues crept into them. So we had a whole bunch of satellites on the shelves with harnessing length issue, wheel tolerance issues, magnetocal wires would break. We'd get handling issues, which would sometimes send some of our processors high current and stuff. Which was a bit of a mystery. We had issues with the wind form being sometimes conductive and sometimes not. So on some satellites, it would cause shorts and actually would cause problems with the processors. So that was kind of like a bit of a mystery issue with that one. It was really difficult to track down. We had board, handling and connection issues. Connections weren't keyed, so we had sometimes that would cause problems with the processors as well. And we had sort of epoxy creeping into some of the connectors as well, and causing problems. So we had a whole load of different problems on a whole load of different satellites, and then we had to try and ship these. We basically had this stock. So we had to improve those, and we also wanted to make some design upgrades to those as well. So we pretty much had to kind of start again, but it was a start from scratch. But it's probably worse starting with partially built, partially broken satellites than it was actually starting from scratch. So it was tough. It was tough. So the rework was tough. I've probably just been over that. Design changes. We wanted to do some design changes. The sats already had known faults. They had to be fixed with the rebuild, and the unknown faults, which had to be detected and debugged. This was at the same time as all the COVID madness. So there's parts shortages obviously probably affected most people here as well. We had parts reclamation from old boards that we had. So we were melting processors off old boards. We were melting various different components off and putting them on new boards, which obviously has quality control issues. It's like, well, that's not ideal, but it's all we could do. We'd have to replace, sometimes you could get replacement components, just, slot in. Sometimes you'd have to rework some footprints for replacement components. So PCB designs sort of consider for that as well. So yeah, it was tough. I'm sure it was tough for everyone, but it was certainly hit us really hard. So, but we were only creating, tens of satellites at that point. So we actually got some parts from, wristwatch man, what's his name? Yeah, Fitbit, from the guys at Fitbit. So Fitbit are one of our investors, the guy from Fitbit. So he was able to get some processors and stuff and some spare parts, so he was really helpful because, he was maybe used to trying to get hold of 1 million or 500,000 parts. And he was like, how many do you need? And we're like, well, maybe 10, maybe 12. And he's like, I think that should be quite easy, so that was pretty good. That was pretty helpful. So non-build issues, that we worked out. Procurement. So we were, I was doing all the procurement for stuff for a big, massive bunch of satellites, and it's very time-consuming. When you've got to go through there, and you each time. Plus, we were building a lab as well, so sort of tooling that lab. So there's always something else that you need. So you get 3/4 of the way through your massive long list, and that part. Obviously, our satellites are made out of a couple of hundred parts if you don't include components, and a whole load, double that or more if you include all the separate PCB components as well. But just ordering all those parts, it all just takes a lot of time. So you get 3/4 of the way through, and you're like, well, I'm nearly there. We'll probably be all right. We probably don't really need a procurement guy. But then something else come up to you, a couple of months later, Tom would still be coming up saying, what can I help you with? And it's like, well, still not through the procurement yet, So eventually we got a procurement guy, and it was like night and day. It was fantastic. So where's Felix? Is he not here? There he is. There's Felix. Looking all embarrassed. So Felix has been great. So more documentation, right? So especially if you've got technicians who tend to come and go, and you want to be able to just put a document straight in front of somebody and say, right, here we go, fire away, away you go. There's the parts, just do that, and they can work away. So if you're always constantly having to transfer information to people, then it just makes the whole process a lot longer. Process improvements as well. So again, documentation of processes, but logging of the processes, logging of faults and stuff. If you're not logging your faults, then it comes to, you've got a sort of ad hoc notes. It's like, well, I think it was that one that had the processor changed, but you know what, I actually can't quite remember, so, well, maybe it's not going to work, So you get that into your ERP system. We use Odoo, which is great, which is really, really good. So having all that stuff in place makes a huge difference. Distractions from the build. Obviously, we're doing manufacturing, but we're a small company. We're just doing a whole load of other stuff. We've got ground station stuff to do. We've got design works to do. We're setting up facilities. We were setting up the lab. Now we're setting up a big facility. There's always something to take your attention away. So you just get into the swing of things and you'd be like, all right, we've got the ground station's fallen over, so we've got to fly out to Germany to fix the ground station. Oh, it turns out it's not fixable. We'll have to build another ground station. That sort of thing. It all takes you away. So this is a bit of a sort of standalone slide, but basically, I just wanted to draw attention to it, that you've always got the sort of tug of war between do we fix it in design or do we fix it in manufacturing. So obviously you've got, if you fix it in the design, then it's fixed for good, and hopefully it's going to be a better fix. If you fix it in manufacturing, you're going to be hacking that onto every satellite in the future, and you've got to improve your quality gates as well. It's like, right, okay, so this little hack here, it's got to be done in this very, very precise way, and if you don't do it like that, or if you do it at the wrong time, then you'll mess something else up. So there's always the sort of unintended consequences. So there's always a question mark as to whether you want to fix it in design or manufacturing. There's no real, real answer to that. There's no textbooks about whether you should fix something in design or manufacturing. You've got to work it out, and you've got to make a judgment call on it. But yeah, we were faced with that sort of daily. Back to the satellites, Unicorn 2F. How are we doing for time, by the way? Yeah, okay. Unicorn 2F. So this was a total success on the first day. It was totally textbook. We built it. We put in some process improvements. We built it. We got it up there. We set everything up. We set the ground station up. We got our TLEs all sorted out. We're like, right, it's going to be here then. Off we go. Ding. There we go. In fact, no, that was it. We parked it. We parked the antenna for that one. So we didn't have TLEs because it was deployed quite late. It wasn't deployed immediately after flight, so we didn't have TLEs. So we parked it at the top, so we didn't have to be concerned about Doppler. And there it was. We sat it there, got the ground station set up, waited for it, ping, off it goes. It was like total textbooks, like high fives all around, like what a team, totally nailed it. So we lined it up for the next one. We still didn't have TLEs. We lined it up for the next pass. It was like a 50-degree pass. So we thought, oh, this is going to be us. We're laughing, We've got a 17-degree pass. We're totally laughing. We'll get this one. No word. We're like, oh, that's a bit disappointing, right? Well, whatever, we'll line up for the next one. Nothing. That night, nothing. A couple of days, nothing. We're like, okay, there's still hope, but this is not looking good. And sadly, we think, so it was its first one, it was on battery, right? And it had been deployed and it had already been sitting there. We didn't have visibility of it for about 8 hours. So it drained its battery, so we got it just before it drained its battery. We did see it once, so we kept trying. We saw it once a couple of months afterwards. But it was the power issues that we'd not had a chance to solve. Still got power budget issues. So sadly, I'm about the dust. And then that was the start of the wilderness years, because we had this wasn't our fault. This one, the first launch orbital transfer vehicle failed. So we were on their first launch. We sort of took the punt. Obviously they didn't have space heritage, and we thought, well, we'll take a punt. And unfortunately, it didn't work out. So we had two satellites there entombed, and they weren't deployed. So that was pretty disappointing. So we like to think that they worked perfectly, but we'll never know. U2I, still looking for it. This was deployed. It's on the timescale. This was deployed not like 2I. We're talking like a few months ago now for 2I, right? June. So this was deployed in June. So we suspect this was a burn wire failure. So we've actually found a failure mode on 𝗖ญ่-𝗁𝗁. We did a lot more testing on 𝗖ญ่-𝗁𝗁, and we discovered that there's an issue with our burn wire getting trapped by the harnessing in some cases on the satellite. So if you basically tie your burn wire in the wrong position, then we've got like redundant resistor burns on the satellite. So if you sort of forget about the fact that if you just accept that you're not going to have redundancy, and then you can use one of your resistors and you can burn your wire, and you can actually, we actually managed to find a way to deploy it reliably, which is what we've done for 𝗖ญ่-𝗁𝗁, and obviously it's worked for J&K. So it's probably what went with I, but we don't know for sure. But then J&K, boom, we got it. So it looks very, very good. 75 hours so far, no resets. So it looks like we solved our power issues. We've got reliable communications. We've had reliable communications for a good few days. Our TLEs have drifted now, but we just started using ION TLE, and it seems that it's not too far from ION. So that's what we're using at the moment. Well, they're not too far from ION. So yeah, it's just so nice to be able to actually reliably transfer data. So we're very much expecting to get images of those, hopefully by the end of the year, but don't quote me on that. I just said it on that. So, but yeah, fingers crossed for that. And we've certainly, like our processes and our sort of capabilities, we significantly improved the testing that we were doing for J&K. We just spent weeks and weeks and weeks testing these things, and it certainly looks like it's paid off. So testing is key, which I'm going to point out as well. LMN, they're in orbit. They're awaiting deployment. They were launched on Friday. So they launched on Friday. So they're going to get deployed, a little Christmas present, 22nd December, 26th. So I don't know who's going to volunteer to do the passes for that. So. Martin looked at the table. So let's see who's going to do that. Testing, as I say, testing is hugely significant. Process now is pretty different to what it was at the start. I mean, at a high level, we design it, we do design tests for manufacturing, we build sub-assemblies, we test all the sub-assemblies, and we make sure that they're passing all their quality gates. The flat sat, we build flat sats up, so we build a sat so it can just in a jig with all the electrical parts in there. We test it out first. We give it a full test to make sure it's actually a functional satellite. Then we build the satellite up into its actual satellite body, put the backplane and stuff on, and then we give that a functional test to make sure everything is being connected properly. We get a verification test to make sure that it performs exactly as it should in space. We do our environmental tests, vibe and bake out. We do sat functional and verification tests again. We integrate into the pod, and off it goes. So that's basically a formalization of the process that we've got. There's a few steps. There's plenty of steps missing there. That's just a sort of snippet from our process flow control chart. But yeah, we spend a lot more time thinking this stuff through and thinking about where we're going wrong and how we can improve. So things are a lot better than they were now. This is what I was saying before. Odoo is our ERP system. So I mean, this is just for, like, we've got lots of different. We've got inventory, we've got manufacturing process, we've got purchasing. There's all sorts of stuff we can do with Odoo. It really comes into its own when you're shipping satellites at the last minute. If you're shipping multiple satellites, we end up at the end. We end up really with like a body, like two sort of sub-assemblies. Really, we've got the body and we've got the backplane. So the body, if you tend to get a problem on one backplane and you want to be able to swap something in, but it's very easy to lose track of what's gone wrong on what satellite. So even just as it goes wrong, we've got eventually we get a sub-assembly. You go through with Odoo, you go through all the sub-assemblies, but you got the sort of super sub-assembly, the satellite body at the end, and you're just like, right, okay, this is how the problem. This backplane is getting logged on there. This backplane is getting swapped over. We're swapping a new one or whatever, and just being able to do that 2 o'clock in the morning. We try not to work till 2 o'clock in the morning, but it inevitably does sometimes happen. So late at night, you're just like, you don't want to be making mistakes. You don't want to get things wrong. You don't want to take the wrong backplane off the wrong satellite, and then you've got 2 dead satellites instead of 1. So this thing really comes into its own. So documentation, we're always trying to improve our documentation as well. We've got this matrix trying to get our documentation all sorted out and go through sort of our test matrix and find out exactly where our gaps are in our documentation. So we're just trying to tighten stuff up, and so far it seems to be working. So that's it. Let's see. This is nearly the last slide. Yeah. Okay. So nearly last slide. Lessons learned. Things I would change. Basically, procurement person earlier on, get a lightweight process in place. You don't need, like when you're talking about processes, you don't need a heavyweight process. But even if it's just a spreadsheet, a checklist saying, I've done this, I've done this, I've done this, you need a process that is going to fit your particular building, capability. Design for manufacturing. I've performed design for manufacturing earlier on. Just an extra level of just taking a week just to fix design issues so that you don't have to propagate those through, right? And propagate hacks through your manufacturing process all the way through on multiple satellites. Finally, don't mix ops procedures with manufacturing procedures. Like getting things straightened out. We used to name our satellites. So let's see, 𝗖𝗁, which was for sort of regulatory purposes, and we would be building 𝗖𝗁, but then 𝗖𝗁 would die, in the lab, and you go, right, so we've got to swap a new one in. So what are we going to swap in? Are we going to swap in 𝗖𝗁G, but we're flying H? Okay, so we're called GH, and it just got into a total mess, So now we just build satellite 1, 2, 3, 4, whatever in the batch, and then at the last minute we assign that to the regulatory number. And last word on the new facility. So we've got a new facility. I don't know if you guys are going to be coming. Anyone's going to be coming out of the new facility tomorrow. So if you are, that would be great. We'll see you there. It's a large space. We're just a little bit west of the city centre. It combines our previously separate office lab and environmental test facility. So there's a whole load of work needed to build that space, but we envisage it as very much a place we can expand into, and a suitable space for getting a high production rate, which is what we want to do. So the last satellites came off the press, let's see, about 5 weeks. So we can build these things pretty quickly, and they should be able to go quickly, more quickly than that even. We can build. We've got the last one built in about 4 days, like from the start. Once we've done the sub-assemblies, built in about 4 days. So yeah, we are building that capability, and that's what we're aiming for, and that's where Tom's passion is, just churning these things out, because obviously we've got big ideas for a large number of satellites up there, and we need to prove that we can actually build these things. And that's us. It's already proven its worth. We brought the ground station back over, worked on it for a couple of weeks, and took it back out to Germany, which we never really been able to do before. So we're really happy with it. And I think that's it, folks. So you can breathe a sigh of relief now. Thank you.